discuss about the internal and external characteristics of DC shunt motor. So if you see here, so we have two identical machines. So one is motor, this one is the motor, and this one is the generator. So this is the panel to conduct this experiment. So if you see here, so we need apparatus. So two rheostats, so which is rated 360 ohms. So 1.7 amperes capacity, and we should have two ammeters. So one is so rated 0 to 2 amperes for field circuit, and this ammeter, so its range is 0 to 20 amperes. So this is for load. We will keep this ammeter in the load circuit, and this is the voltmeter. So we will use up to 0 to 300 volts range. And if you see there, so this is the loading rheostat. So by using that load, so we can apply the load. Now let us look into the circuit diagram. So this is the circuit diagram to conduct the experiment. So here if you see, first we need to start the motor. So for to start the motor, we need to use a 3-point starter, so LFA. So because it is a shunt motor, so we will use a 3-point starter. So when this motor started, the mechanical output from the motor, so it is given to the generator. From the generator, so we will get the induced EMF, so we will get EMF. So if you look into the circuit diagram, here we have so SPST switch, a rheostat, and field winding ZZZ, and there is an ammeter here. So here initially we will open the field circuit. So here if you see, this is the SPST switch. So the field circuit is opened initially. So when field circuit is opened, when I start the machine, when I start the motor, a small amount of EMF is induced in the generator, DC generator. The small amount of EMF induced, this is because due to small amount of flux stored initially, that is called as residual magnetism. Because of that residual magnetism, small amount of voltage is induced in the DC generator. When I close the SPST switch, then there is a provision for the field current, then maximum amount of EMF is induced in the DC generator. That we will observe by conducting the experiment. And if you see here, so here we have load. So initially I on the machine without load. So initially I will on the machine, so without any load. Now we will start the experiment. Now let us check. So now I am closing the DPST switch. Now I am starting the machine. So machine started running. Now I will check the speed by using the tachometer. Now the speed is around 1100 RPM. Now I will increase the speed by adjusting the motor field rheostat. Initially I kept at the minimum position. I will increase the resistance. Then the speed also increases. Now the speed is so around 14-15 RPM, so which is the rated speed. So if you observe the voltmeter here, so this voltmeter I kept across the DC generator. So initially the induced EMF is around 30 volts. So here 30 volts. So this is due to the residual magnetism, small amount of EMF is induced. And if you see here, this is the field current. So initially field circuit is opened, therefore field current is 0. As there is no load, there is no current here. This is the armature current, this is the load current. So initially as there is no load, the ammeter showing the 0 deflection. Now I will close the field circuit by closing this SPST switch. So now if you observe the voltmeter, as and when I closed the SPST switch, the voltmeter deflected. So voltage induced is around 210 volts DC volts, and the field current is, see here, the field current is around 0.33 amperes. And here if we see, as there is no load, the load current is showing 0. So I want to increase the voltage. So actually this machine is designed for 220 volts DC though, therefore, so I want to increase the generated EMF from the generator, so that I can done it with by decreasing the generator rheostat. So as and when I decrease the generator rheostat, so here I am decreased the, initially generator rheostat is at maximum position, I am decreasing. So if you see here, voltmeter deflection, so it is 220 volts now. As it is reached the rated voltage, now I will apply the load. So initially, so load, if you see there, main switch, so it is okay, it is on mode. Okay, now I on the main switch, but I didn't loaded anything. Now I will on the 1 ampere switch. Yes, so see here, we see the ammeter deflection, so it is showing around 1 amperes load. So initially 220 volts voltage is generated. As I loaded the machine, the voltage get reduced. So initially 220 is there, now it is 210 volts. Now I will apply the 2 amperes load. I am applying the 2 amperes load. So now voltage is still reduced below 210 volts. Now it is around 206 volts. Now I will still increase the load. See here, voltmeter, in the voltmeter the voltage is getting still reduced. Now I will increase the load even more. See here, the voltage is again reduced. Like this, so we will apply the load. Slowly the voltage is getting reduced, terminal voltage slowly falls down. Now we need to plot the internal and external characteristics. So here if you see, so these are the characteristics model graphs. So we will plot the internal characteristics, so between generated EMF versus armature current. So here if we actually armature current is not directly calculated, because so we are calculating load current, we are measuring the load current from load ammeter, and we are measuring the field current from field ammeter. So if we sum the both IL and IF, we will get the armature current, and so we will get the voltage. So load voltage is directly we can measure from the voltmeter reading. Load current also we placed the ammeter, and field current also we placed the ammeter, and we will calculate IRA drop, and finally we will calculate the generated EMF. EG is equal to terminal voltage plus IA into RA. We will plot the internal characteristics for generated EMF and armature current, and external characteristics for terminal voltage and load current. So we will get the graphs like this. So like this we need to perform the experiment. Now I want to turn off the machine. Slowly I will increase the resistance of the generator, and then so actually before that I need to turn off the load. Actually I will turn off the load, and next we need to decrease the resistance. So speed is getting reduced, the speed also getting reduced, and I will open the DPST switch. So like this we need to conduct the experiment. So by this experiment, so we can observe both internal as well as external characteristics of DC shunt generator.